We're going to be calculating the Gibbs free energy from enthalpy and entropy and predicting which reaction is spontaneous, whether the forward reaction, the reverse reaction, or neither. In this example, a reaction vessel is filled with a reaction mixture of the reactants and products at constant temperature of 129 degrees Celsius. The reaction enthalpy is measured as negative 1,237 kilojoules, and the reaction entropy is measured as negative 3,088 joules per Kelvin. Calculate the Gibbs free energy and predict which reaction is spontaneous. I want to start off with my given information. We are asked to solve for delta G. We have delta H. We have delta S. And we have temperature. In order for us to use the formula, delta G, delta H, and delta S have to be in the same units. And since this example did not specify which units, I'm going to go ahead and convert my entropy to kilojoules. Remember, 1 kilojoule is 10 to the third joules. So this will equal to negative 3.088 kilojoules per Kelvin. I also want to remember to convert my temperature to Kelvin. And since my initial temperature is given in 1 decimal place, my converted temperature should also have 1 decimal place. The next thing I want to do is plug into the formula delta G equals delta H minus temperature times delta S. I'm going to go ahead and plug in my numbers. I'm going to clean up. And this is going to give me a final answer of delta G equals 5 kilojoules. Since delta G is a positive number, that means the way this reaction is written in the forward direction is non-spontaneous. Therefore, the reverse reaction is spontaneous. Let's take a look at another example. A reaction vessel is filled with a reaction mixture of the reactants and products at constant temperature of 114 degrees Celsius. The reaction enthalpy is measured as negative 172 kilojoules, and the Gibbs free energy is measured as 0 kilojoules per Kelvin. Calculate the change in entropy and predict which reaction is spontaneous. So I'm going to start off with my given again. And this time, they've given us delta G. And we have delta H. And we're asked to solve for delta S, and temperature is given as 114 degrees Celsius. Delta G and delta H are in the same units, so that means I just have to convert my temperature. And since our temperature is given in 1 decimal, that means my converted number should also have 1 decimal place. The next thing I want to do is plug into the formula delta G equals delta H minus temperature times delta S. I'm going to plug in my numbers. I'm going to clean up, so I'm going to have to add 172 on both sides. And then I'm going to have to divide by negative 387.2 on both sides. So we solve for entropy. Entropy is negative 0.44 kilojoules per Kelvin. But we need to talk about whether this reaction, the way it's written, is spontaneous. Delta G is 0. So in the forward direction, the reaction is not spontaneous. In the reverse direction, it's not spontaneous. When delta G is 0, we can say that the reaction is at equilibrium. Good luck and keep practicing.